So, basically this topic is about the energy transfer by the cell in a given circuit, that is power. Of course, if we keep a circuit on for a very long time, we can transfer infinite energy, but that is not the point. We would like to know what is the rate at which the energy is transferred. That is why we define power, that is energy per unit time, watts. So, what are the different cases, and when the maximum power is transferred and the bulb, these kind of questions may be asked in your previous in your exams. So, basically the concept starts from here, the power in resistors, power in resistors. So, basically when two resistances are especially connected, you can see that there are two formulas. Power through any resistor is I square times R, and P is also given as V square by R. It is especially true for resistors. So, when to use which formula, I square R, when to use V square by R. So, my dear student, this is especially used when the resistances are connected in series. Suppose let us say this is R1, let us say this is R2, and we would like to comment or would like to know what is the relation between P1 and P2. What is the relation between P1 and P2? So, it is always better to use I square R, because P1 and P2 would have same current I. So, P1 will be equal to I square times R, R1, and P2 will be equal to I square times R2, and this is how basically you can relate their powers. Whenever they are connected in series, their power can be related by I square R. Same thing similarly, if resistances are connected in parallel, if they are connected in parallel, of course it is obvious to not go by current if they are connected in parallel, and we would like to comment on their powers P1 and P2. These resistances can also represent bulbs, because bulbs are similar as resistances. Then of course P1 will be equal to V square by R1, and P2 will be equal to V square by R2. So, you can divide and you can see the V square gets cancelled out, and it comes out to be inverse ratio of R2 by R1. So, very important to understand. We will see in different situations how to apply these two concepts, but the basic idea is whenever the resistance are in series, I square R, when they are in parallel, V square by R. Second expression, power in cell, power delivered by cell. So, basically my dear students, power delivered by any cell or voltage is product of voltage and current. So, if you would like to know how much energy will it deliver, to the external resistance R, how much energy will it deliver to the external resistance R, then that is nothing but the product of potential difference V and current in the circuit Vi. So, power delivered will be P delivered to the resistor will be equal to V I, V you already know is E minus IR and into I. So, that is E minus I square, EI minus I square internal resistance R, that is power. So, one important thing here is, my dear students, when you put I equal to 0, the power delivered is 0. When you put I equal to E by R, again power delivered is 0. So, basically power delivered will be a function which is varying like a quadratic. So, it would have a minima and maxima. Minima is 0, we need to find the maxima, and that is called as maximum power concept. Maximum power delivered. So, basically the concept is very simple. When a battery of EMF E and internal resistance R is connected to some variable resistance capital R, we are varying this we would like to know when this resistance will get the maximum power. So, power will be maximum, power delivered will be maximum P max when this external resistance is equal to internal resistance. We are not going to derivation, we are just writing the formula. When this external resistance connected is equal to the internal resistance of the battery, then power delivered will be maximum. You can also determine this as, it means in that case the external resistance will be equal to small r and in that case the power, you can see for this case the current in the cell will be equal to E by 2R and power comes out to be I square R. Directly when you put the values it becomes E square by 4 times R. So, this is the maximum power and this is the current when maximum power is delivered to resistance R. Remember, whenever this external resistance is equal to internal resistance, maximum power is delivered. Very important concept. Now, let us go to the third point, that is electrical bulb. So, basically bulbs, when you draw an electrical bulb, it is nothing but a resistance. Yes, bulb is a resistor, but one thing about the bulb, it contains a filament and that filament can break out if you apply power more than the capacity of this bulb, and for that we write power rating PR and voltage rating. Let us say power rating is 100 watt and the voltage rating is, let us say, 50 volt. What does this mean? These are the maximum power and maximum voltage for bulb. So, basically when I say, when I bought a bulb of 100 watt, it means it will give me a power of 100 watt when I apply the voltage of 50 volt. If I apply lower voltage, then of course it will not deliver 100 watt. It will deliver 100 watt only and only when you apply 50 voltage. So, remember this thing, it is not that if you write 100 or if you bought a 100 watt bulb, it will always give us 100 watt even if you do not connect it to electricity. No, that is the maximum power it can deliver when you connect it with some 50 volt plus minus voltage rating. So, basically you can also determine the current rating, what is the maximum current which can pass through it is basically power rating upon voltage rating. So, we can determine from here, we can determine two things. One is what is the maximum current which is allowed to pass through. Maximum current again is maximum power, that is power rating upon voltage rating, and what is the resistance of this bulb, that is V rating square upon power rating. Very important to understand. This is the maximum current. This will help us to identify which bulb will fuse first, and this is the resistance of the bulb, voltage rating square upon power rating. Very standard result, and these will help us to solve the problem.